Alright, so for me, we're starting off on page 6 here with our limits notes. Alright, so what a limit is, like kind of defined in a more mathy way here, is the limit L of a function is the value that f of x, so remember f of x is just function notation, the function notation way of saying y. Okay, so the limit L of a function is the value that f of x approaches as x approaches some value a. Okay, so as x approaches some value a, y is going to approach some other value. Could be the same value as x, or it could be a different value for x. Okay, now off to the side here, they've just said it in like a bit more of a extreme shorthand here. Okay, but we're gonna want to know that for a limit to exist, super important to know that it must approach the same value from both sides. Okay, so when x approaches some value a, y has to approach the exact same value from both the left-hand side and the right-hand side. Okay. All right. And if you want to highlight the more shorthand version of saying the exact same thing that I just read off, that's on the right-hand side there. Okay. All right, so let's take a look at our example for finding limits numerically. Okay, so we're told to evaluate the limit as x approaches 0, and this part right here is our f of x. Okay, so as the limit for x approaches 0, evaluate the limit of 1 plus x to the power of 1 divided by x. Okay, so we're given a chart here to figure out what the value for f of x is going to be as we approach x from the left and from the right. Okay, so here's what our game plan is going to be. We're going to choose values of x that get closer to 0. Okay, so why are we choosing values of x that get closer to 0? It's because the question says that the limit, we're trying to evaluate the limit as x approaches 0. Okay, the number that we choose, like for your values of x to get closer and closer to, it comes from this number right here. Okay, so just something to keep in mind. Okay, so we're going to choose those values of x getting closer to 0 from both sides, so both left and right hand side. And we will discover what f of x approaches. So now, I said this out loud, but I didn't really write it out. So this part right here, that's the f of x part. Okay. All right. So choosing values of x approaching 0 from the left. So for our number line here, we're approaching from the left, so we're going this way. Okay, so I'm going to choose negative 0.1 for my first value because that's pretty darn close to 0. Okay, and if I put negative 0.1 into f of x, what we'll get here is 2.8679. ... Number keeps on going on forever and ever and ever. Okay. The next value that I'm going to choose is negative 0.01. Okay, getting closer, and if I put that into f of x, that's going to be 2.7319. Number keeps on going on. Next number I'm going to choose to substitute in for x is negative 0.001, and that'll give us 2.7196. Number keeps on going on forever. Okay, so what we can conclude here, right, is as we approach 0, okay, the number that f of x is approaching slowly but surely, okay, we're going to write it to 2 digits after the decimal here, so it's going to be 2.72. Okay, so we're just taking this number, we're writing it to 2 digits after the decimal place, and we're just rounding that last digit there. Okay, so now let's approach 0 from the right hand side. Okay, so numbers that I'm going to choose, 0.1. If I plug that into our f of x, I'm going to get 2.5937. If I plug in for x 0.01, I'm going to get 2.7048. Oh, these numbers keep on going on forever. I should have wrote ... after both of those. And then the next closer number to 0 will be 0.001. And if I plug that into f of x, I get 2.7169 ... Okay, so you're going to want to, like for any question like this, you're going to want to pick 3 numbers for your value of x approaching from the left, and then 3 numbers approaching whatever value x is approaching from the right. And just to see what number it's getting, like f of x is getting closer and closer and closer to. Okay, so for the case we just did from the right, as x approaches 0, our f of x is going to approach 2.72, which is great because that means it's approaching the same value from the left and from the right. That's what you want to see. Okay, and the reason why you want to see that is because, remember, for a limit to exist, it must approach the same value from both sides. That's why that's important. Okay, so maybe I'll write it over here since I've got more room. So since, well, I'm going to write f of x instead of it. So since f of x approaches the same value from both sides, we can state that the limit as x approaches 0 of 1 plus x to the power of 1 over x is approximately equal to 2.72. All right, so you're going to have to know how to figure out limits numerically, so how we just did it, but also you need to figure out limits by looking at a graph. Okay, so since most functions are in the form of y is equal to f of x, we can evaluate a limit by discovering what y approaches as x approaches some value a. Okay, so looking at our example, we got to evaluate the following using the graph. So let's take a look at a here. So we're asked to figure out the limit as x approaches -1. So We're assuming here, without any additional signage, that x is approaching -1 from both the left and the right-hand side. Now, it's saying, okay, what is the value of f of x as x approaches -1? Okay, so this is where we take a look at our graph. Okay, so for A, it's referring to this point right here. Okay, because that's where x is -1. So what I'm doing here in my brain is I'm kind of tracing my finger along the graph here from both the left and the right hand side, and I'm like, oh, okay, so as x approaches -1 from both the left and the right hand side, y is gonna approach or eventually become 3, okay? Because we're assuming each one of these tick marks is like 1 unit. So what I'm gonna write here is I'm gonna say equals 3. Okay, so I'm just writing down what I said out loud here. So y, this means that y is approaching 3. Okay. Now we'll do the same thing for b. So figure out the limit of f of x as x approaches 9 from both the left and the right hand side. Alright, so let's find x is equal to 9. That's going to be right there. Okay. So again, I'm kind of mentally tracing my finger from both the left and the right hand side, and like I'm looking here, and this, not a very straight line here, okay, but I can say that approximately as x approaches +9, y is going to be approaching -4.5, -4.6, somewhere in there. Okay, I'm going to take a look at this. I'm going to say maybe 4.6. If you wrote -4.5 on an exam for a question like this, I'd still mark it right. There is a little bit of wiggle room with the graphs here. Okay. So if you're just a teeny tiny bit off with a graph, that's okay. So this is just saying y is approaching -4.6. Okay. C is just saying, what is f of -5? Okay, so what is our y value when x is equal to -5? So let's take a look at that. That's going to be right here. Okay, so we can see that there's a hole in the graph there. So right at x is equal to -5, the graph does not exist. Okay, so I'm going to write that, but I'm going to use some math symbols just to write that. So you could write like does not exist, DNE, or I just write a 0 with a line through it. Either or will be fine. Okay, so what we're saying here is where x is equal to -5, there is no y for this graph. Okay, so C is just figure out what the y value is, which in this case does not exist. Okay, but since we don't have this sort of notation, it's not really a limit, it's just figuring out at a specific point. Okay, we're not approaching from the left or the right. For C, we're just figuring out at a very specific point. Okay, now for D, we're looking at the same point, except for now we're figuring out the limit of f of x as x approaches -5 from both the left and the right hand side. Okay, so this is going to be a little bit different. Okay, so maybe I'll write C and D. So again, mentally tracing my finger from the left and the right hand side, and I'm noticing that from the left hand side and the right hand side, the graph is approaching 4. Okay? That's as x gets to -5, but it's not right at -5 just yet. Okay? So that's why we get a different answer for D. So we're going to say is equal to 4. So what we're saying here is y is approaching 4, even though there's no dot at like y is equal to 4. Okay. So what I mean by even though there's no dot, so like even though this hole right here isn't filled in, so it's not a dot, okay, we can still say that the graph is approaching, that f of x is approaching 4 as x approaches -5. Okay. Part E asks us to evaluate f of 2. Okay, so when our x value is 2, what is what is our y value? Okay, or f of x. So notice here, we've got 2 points where we have f of 2. Okay, but only one of these points is like a closed circle or a filled in dot, whatever you want to call it. So that's going to be what we pay attention to here. Okay, because the graph actually exists at this filled in dot. It does not exist at this hole or this open circle, whatever you want to call it. Okay, so that's why I'm going to say for E, which I should maybe label that there, okay, that this is going to be equal to 2. Okay, so when x is equal to 2, y is equal to 2. Okay, now f asks us to evaluate the limit of f of x as x approaches 2 from both the left and the right hand side. Okay, so I guess I'm going to add this is E and f here, and then this point is more so just f. Okay, so I might have to erase this part. So again, mentally drawing my finger from the left hand side, it's like, okay, from the left hand side we're approaching 2, but from the right hand side we're approaching -2. Okay, so this is weird because we're not approaching the same value. Okay, now going back to our definition, for a limit to exist, you have to approach the same value from the left and the right hand side. So that means this is not going to exist because it does not approach from the exact, or it does not approach the same value from the left and the right hand side. So does not exist, or a 0 with a line from it or through it. Why? Because it's not approaching the same value. Okay, limit of a constant. Okay, so let's say we're asked what is the limit of -2 as x approaches as x approaches 5. Okay, so they've given us a nice diagram of that. So like this expression is just saying f of x is equal to -2 here. Okay, so that's why we have a horizontal line at y is equal to -2. Okay, so the limit of -2 as x approaches 5 from both the left and the right hand side, it's still going to be -2. So we can say that in general, the limit of c as x approaches whatever value a is from the left and the right hand side, like that limit will equal c. And c is an element of a real number there. And you can assume that for any constant there. Because it doesn't matter, whatever your value of x is, your y is always going to be whatever c is. Ooh. All right, limit of x. So let's say we have, or we're asked to evaluate the limit of x as x approaches 3 from the left and the right hand side. Okay, so remember that this part is saying f of x, or y, if you want to call it that, if you're not using function notation, is equal to x. Okay, so I'll write it the other way too. Okay, so what that means is whatever value x is, y is going to be that same value. Okay, so the limit of x as x approaches 3 is going to be 3. So we can generalize that the limit of x as x approaches any value is going to be whatever that any value that's been chosen is. Okay, and off to the right hand side we've got a picture of what that graph looks like with y is equal to x. Okay, so it's just a straight line that goes through the origin. So those two are pretty straightforward. Okay. Now, evaluating the limits of functions. Okay, so to find the limit of most functions, you can simply substitute the value into the function and figure it out. Okay, so for example, if you're trying to evaluate the limit of f of x as x approaches some value a, just plug a into whatever function you're given, and whatever number you get is the limit evaluated. Okay, but that's not very interesting. Okay, where life gets interesting is when 0 starts to get involved here. Okay, so just quickly going over properties of zeros, which everybody already knows here. So 0 times any number here, looking at that part there, is going to be equal to 0. 0 divided by a is going to be 0. Okay, now where things get spicy is when a is divided by 0, that's going to be cause the function to be undefined, or if you get a situation where it turns out that the function ends up being 0 divided by 0, that's going to be indeterminate, aka it cannot be determined. Okay, so those last two situations are going to be the more interesting situations, and they're going to be what likely most of your questions are going to be focused on. Okay, so if your limit is indeterminate, or even if it's undefined, you're going to have to add that into your notes. Okay, what you're going to have to do is you're going to have to simplify the function to make it determinate. Okay, so usually that involves some sort of form of factoring and canceling out factors in order to make the function determinate. Okay, so let's take a look at this first example given here. Okay, we're asked to evaluate the limit of x squared minus 16 divided by x minus 4 as x approaches 4. Okay, so I'm just going to do a little side thing like really quickly. You don't have to write this part that I'm going to do in blue, but I'm just showing you, okay, if we plugged in x is equal to 4, okay, so 4 squared minus 16 divided by 4 minus 4, right? 4 squared, that's 16, right? So we get an indeterminate situation here if we just go ahead and plug in the value that x is approaching. Okay, so that's how you know, okay, this is a function that I need to factor, cancel out some factors in order to make this determinate. So I'm going to write here indeterminate therefore factor. Okay, so if you're wondering if you need to write this stuff that's in blue, you don't have to. But if you're wondering why we're doing all of this, it's because if you just quickly sub in the value that x is approaching, and if you result in either undefined or indeterminate, that's why we need to factor. All right, so I'm looking here, and I notice I can do a difference of squares. So I'm going to go ahead and do that. It is a little bit annoying to write the limit as x approaches 4 every single time, but yes, you do need to do that. So for our difference of squares, we're going to get x minus 4 times x plus 4, and then divided by x minus 4. In the denominator, we've got the same factor in the numerator and denominator, which means we can cancel those out. So limit as x approaches 4, okay, that's going to give us x plus 4. And now we can substitute in. Okay, so limit as x approaches 4, substituting in 4 where x is, we get 4 plus 4, which we know is 8. And that's our final answer. So that's how you would evaluate the limit for this function. All right, our next limit. So evaluate the limit of the square root of x plus 4, and then minus 2, all divided by x. So again, if we substitute in 0, and the reason why we're doing it is because that's what x is approaching. So if we get 0 plus 4 minus 2 divided by 0, right? Doing this super quickly, okay, 0 plus 4, we all know that's going to be 4. The square root of 4 is 2. Okay, and this turns into another situation where we got an indeterminate function given to us. Okay, so indeterminate, therefore, this case, because we have a radical, it's going to be a bit tough to factor here. But what we can do instead, like the main goal here, will be to simplify. And how we can simplify when a radical is involved is going to be to multiply by the conjugate. Okay, so that's usually what you're going to do when radicals are involved. So limit as x approaches 0. So maybe I'll have to squeeze this in here. So we'll do x plus 4. So the conjugate is just when you change the sign between the radical and whatever other value you have. We're going to times both the numerator and denominator by that. Okay. So for this, we're going to get, sure, I'll do this a bit stepwise. So square root of x plus 4 squared, because this times this can just be square root of x plus 4 squared. Okay. Now this times this is going to be plus square root, or plus 2 times the square root of x plus 4 minus 2 times square root of x plus 4 minus 4 divided by, and we've got x times x plus, or the square root of x plus 4 plus 2 we're just going to leave the denominator factored just in case things work out that we can actually use that to just cancel out any one of these factors in the denominator once we work out the numerator. Okay, so in the numerator, these two cancel out. The square and the square root cancel each other out. So limit as x approaches 0 is going to be x plus 4 minus 4 divided by x times x plus 4 plus 2. Okay. Oh, I forgot that 0 as x approaches 0. Okay, so positive 4, subtract 4. That's going to cancel each other out too. So we have x in the numerator, x times square root x plus 4 plus 2 in the denominator. And looky here, we can cancel out those x's. Okay? So that's the simplifying we needed to do, that canceling, that results in this no longer being indeterminate. Okay? So at this point, this is when I'm going to substitute in. Okay? And maybe I'll do this up here. Okay? And I'm going to substitute in 0 wherever I see an x. Okay? So limit as x approaches 0, so we have 1 divided by square root of 0 plus 4, and then plus 2. Okay, so 0 plus 4, obviously that's 4. The square root of 4 is 2, so we're going to get a quarter. That's going to be our final answer there. Okay. Moving on to our next one here. Okay, so for this one, again, I'll do this really quickly. If we substitute in 7 wherever we see an x, notice how we're going to get indeterminate. So that's why we need to simplify. Okay. So in this case, what I'm going to do in order to simplify is I'm going to focus on the denominator and make them just into one fraction here. Okay, so I'm going to do that by multiplying the numerator and denominator of the first term by 7 and then the second term by x. Okay, so the limit as x approaches 7, so we have x minus 7. I'm going to draw this divide by line a little bit bigger, so hopefully it's easy to tell that difference between the divide by sign in the denominator. Okay, so for the first term, that's 7, and then minus x, all divided over 7x. Okay. Now, what we're going to do here, okay, I think I'll do this a little bit stepwise so it's easier to follow. So I'm just turning this divide by sign into this. Okay, 7 minus x divided by 7x. Okay, now to divide our fractions here, and maybe I should be putting that in brackets. There we go. Okay, so flip the divide by sign into a multiply sign and then flip the fraction that comes after it in order to figure this out. So 7x divided by 7 minus x. Okay, now look here, we've got two factors that look awful similar, but they're not exactly the same. Okay, now again, I'm just doing this like slowly so it's easier to follow here. So limit as x approaches 0. I'm going to factor a negative out of this denominator here. A -1, sorry. So what we get, we got -1 times by, now you could go -7 plus x, but it's still a little bit confusing, so I'm just going to kind of monkey switch these two terms so it's a lot easier to see where I'm going. So x minus 7. Okay, and now we can cancel those two terms out. So the limit, as x approaches 7, 7x divided by -1 is just -7x. Okay, so at this point, now we can substitute in. So we're subbing in x is equal to 7. So that's going to give us -7 times 7, which is equal to -49. Okay. One thing I do want to say here is that, like, you may be wondering, okay, what's expected of me on a test? Do I need to go through a whole proof that something is indeterminate and write out all of my work for that? Nope. Okay, but I do need you to check whether something's determinate or indeterminate before you go about your work here. Okay, so that's a mental check you need to do. Okay, if you go ahead with these steps, I am assuming that you know that something is indeterminate. Okay, so basically, if you did exactly what I did, but you didn't write any of this stuff here, that's okay. So long as you get, like, you simplify correctly, right? And then you substitute in at the end, like that is okay.